Welcome. We shall see about Mosfet. Mosfet stands for Metal Oxide Semiconductor Field Effect Transistor or IGFET, Insulated Gate Field Effect Transistor or Mosfet or IGFET Insulated Gate Field Effect Transistor. So it is classified as Enhancement Mosfet and Depletion Mosfet. So by applying the transverse electric field across an insulator deposited on a semiconductor material, thickness and therefore the resistance of a conducting channel of semiconductor material can be controlled. In depletion MOSFET, the controlling electric field reduces the number of majority carriers, and in depletion MOSFET, the electric field causes an increase in the majority carrier density in the conduction region of the transistor. So the construction of enhancement MOSFET is, we have the gate terminal. So MOSFET is a 3-terminal device, we know. So this is the gate terminal. We have the source and drain. We have the source, drain and gate, and this is the substrate. So unlike BJT, here for N channel MOSFET the arrow mark goes inside, and for P channel MOSFET the arrow mark goes outside for the P channel MOSFET. So this is substrate, the arrow mark going outside is P channel, source, drain and gate terminal for the MOSFET. So the construction of MOSFET is like, we have the P type of substrate, and here a N plus region and a N plus region, and there is a channel like this here. So here we have the connection for gate, an aluminium region and the gate connection. So here we have the connection for source, and from this N region for the drain. So the connection is like, for enhancement MOSFET, the gate is connected to the positive of the voltage, the source is connected to this point, and substrate connection here, the drain voltage which is connected to drain, VDD. This voltage, since it's gate voltage, it is called VGG. So gate voltage is connected to the positive aluminum layer. Here we have a thin SiO2 layer. This layer is a thin SiO2 layer. So induced N channel is there. So there is not a channel at first itself. We have an induced N channel. So because of this positive VGG voltage, a positive charge is created here in this gate region, followed by a negative charge here and a positive charge here by charge inversion, and finally between the source and drain a negative charge is there. So from the source to drain electrons are traveling, and there are more electrons gets gathered in the drain region, and the drain current ID increases for enhancement MOSFET. So the different distance between the source and drain is 1 mil or 10 to the power minus 3 inch. So this is called IGFET because of the insulated layer of SiO2. So here we have the drain and transfer characteristics. The drain characteristics is drawn for VDS and ID for different VGS voltage. So this is for VGS is equal to different VGS voltage. We have the drain characteristics. So VGS is equal to 8 volt, 4 volt, 2 volt. So this positive voltage is enhancement MOSFET, and the negative voltage is till the 0 volt, and this is for VGS is equal to minus 1 volt, minus 2 volt, etc. So this region is depletion MOSFET. So the current starts to increase from a threshold voltage called VT, And this is the drain characteristics. The curve is VDG equal to VDS minus VGS, and VDS at is VGS minus VT, the threshold voltage. The transfer characteristics can be plotted even from the drain characteristics itself. So this is the transfer characteristics. It's drawn for VGS and ID for different VDS values. So by projecting this VDS, this drain characteristics itself, we can draw the transfer characteristics. So the curve is like this. So it is 0 for some time and then starts to slowly increase. So it's 0 till the cut-in voltage 2 volt, which is the threshold voltage. So K is equal to ID on by VGS on minus VT whole square. So the equation for the drain current ID equal to IDSS into 1 minus VGS by VP whole square. VP is the pinch off voltage, cut-in voltage. So this is the enhancement MOSFET. For the depletion MOSFET, the difference is we need to give a negative voltage, gate voltage. So the gate voltage, if it is negative VGG here, and a channel is already there here. So what happens actually is for depletion MOSFET, so a channel is already present. So if we draw the construction diagram, so this is the thin SiO2 layer, N plus region and N plus region for the source and drain connection, and here we have the gate connection. Here we have negative followed by positive voltage, and source is connected to the same point, and substrate connection here followed by VDD voltage. So this is the gate voltage VGG we know, and this is the drain connection, and we have the drain current ID. So this is a P substrate, since it is N channel MOSFET, and there is a N channel available first itself. So in this aluminum layer, in this gate connection, because of this negative voltage, a negative voltage is found here, followed by positive here, negative again because of charge inversion, and here a positive voltage. So here what happens is there is a channel already and electrons are going from source to drain. Now positive voltages are induced between the source and drain, so the charge recombination happens here, and so less charge carriers goes to the drain. So the drain current is less. There is depletion of the charge carriers in the drain, so it is called as depletion MOSFET. Symbol wise, since there is a channel present already, we have a continuous line. For N channel arrow mark goes inside, and for P channel arrow mark goes outside the MOSFET. So because of the negative voltage here and charge inversion, there is depletion of charge carriers. And so same way we can draw the transfer and drain characteristics. So in the transfer characteristics, so this is the curve. So IDSS is this point for different VGS positive voltage and VGS negative voltage, and this is the drain current ID. So this side it is depletion MOSFET, and in the positive side it is enhancement MOSFET. Then we have the same equation, ID is equal to IDSS by 1 minus VGS by VP whole square. So handling precautions of MOSFET. MOSFET is very susceptible to overload voltage and may require speed handling during installation. It gets damaged easily if not properly handled. This thin SiO2 layer between the gate and channel is damaged due to the high voltage and even by the static electricity from the human body. Comparison of N and P channel. P channel is very popular because it is much easier and cheaper to produce than N channel. Hole mobility is nearly 2.5 times lower than electron mobility. And regarding the depletion and enhancement MOSFET, we know the difference in symbol. Channel exists permanently in depletion, whereas in enhancement MOSFET, channel is physically absent, and it happens when the gate voltage is applied. Operation. Depletion MOSFET can be operated in depletion mode and enhancement mode, whereas enhancement MOSFET can be operated only in enhancement mode. Current flow, drain current flows in the application of drain to source voltage at VGS equal to 0, while in enhancement, no current flows on the application from drain to source voltage. Next, we shall see a special type of MOSFET called CMOS, complementary MOSFET. The diagram is like this. We have two MOSFETs together. We have the SiO2 layer here. We have N plus region and a connection VSS, a P plus region, the connection S2, source 2, and then P channel here and a P plus region. So this is a P channel MOSFET. So this is P channel when on, and it has a N type of substrate in this place. And then this P region, it is connected to the gate 2. This is gate 2, which is connected to VI voltage. Sorry, this is the gate 2 which is connected to VI voltage. We have the connection from this P region, which is drain 2, which is connected to V0 voltage. So from here we have the other type of MOSFET, which is N channel MOSFET. So here we have the N plus region and another N plus region, which is this is the drain connection, drain 1 connection, which is connected to V0, and this is the gate 1 connection, which is connected to this same V1 voltage, and this is the source 1 connection, which is given to another P plus region connected to the ground. Source 1 is connected to ground. So this is the CMOS, complementary MOSFET structure. So this is the SiO2 layer. And so this when on, there is a N type. So this diagram is equivalent to a MOSFET like this, where we have the gate connection. And this MOSFET here, gate connection is here. This is N channel MOSFET and this is the P channel MOSFET. We call this as Q1 and this as Q2. So here we have VSS is equal to 5 volt, and this is the substrate connection, and this is drain. Both the drains are connected. Q1 and Q2's drains are connected. And this is the source here. This is the source here connected to ground. This is the substrate connection, and both the gates are connected to the input voltage VI, which is 5 volt. So this is one state. So when this is equivalent to Q2 off, it is resistance is high, and when Q1 is on, R1 is low. We take the output V0, which is equal to R1 into VSS by R1 plus R2, which is equal to 0 volt, and here it is grounded. So here we have the VSS connection and the leakage current I leakage. So when the input voltage is high here, when VSS is equal to, so the connection here is like this. So here this is the P channel MOSFET, which is the P channel MOSFET, which is Q2, and this is the N channel MOSFET, which is Q1. So both the drains are connected to V0, output voltage V0. Both the drains are connected to the output voltage V0 here. Both the source 2 is connected to VSS, and same way here source 2 is connected to VSS. Source 1 is connected to ground. Both the gates are connected to the input voltage Vi. So when Vi is on, Vi is in high state, what happens is this like n channel MOSFET, this one is on and this one is off. So when this Q2 is off, the resistance here is high, and this one is on. So the output voltage V0, which is taken from here till ground, V0 is equal to R1 into VSS by R1 into R2. So here we have R2 is high, so this becomes 0 volt. So when input is high or high state of high, the output is low, and when the input is low, the output becomes a high state. So this is called as complementary MOSFET. So these are about the MOSFET, enhancement depletion MOSFET, and another special type of MOSFET called complementary MOSFET. Thank you.